Hello, everyone. My name is Guilherme, and today we will talk about using NLP++ to build a Brazilian address cleaner in HPCC Systems. This project was implemented with the collaboration of David de Hilster, and this session will be followed by our academic partners at RV College of Engineering, so be sure to stick around. So I graduated with a Bachelor of Engineering in Computer Engineering in Brazil. I am a master's student in management of production systems, and I am a software engineer at LexisNexis Risk Solutions. So it's just a quick introduction about me. So about this project, the objective is to build a Brazilian address analyzer and cleaner that can improve the current cleaning process with the benefit of being a transparent process with easy identification and correction of problems. So now we have to talk a little about address cleaner. What is an address cleaner? As the name implies, it's a tool that performs an address cleansing, which is the collective process of standardizing, correcting, and then validating a postal address. The address verification process includes multiple steps, such as parsing, which is the assignment of address elements into the appropriate fields. The second step would be the validation against postal data. The third step would be the formatting. So addresses are stricter according to international postal standards. In this case, the Brazil standard. The next step would be the transliteration. That is basically when data is converted. So is the conversion between non-Roman characters and Latin characters. And the last step is the address enrichments, which is when the tool provides additional information that helps you better understand and use the address data. So this is how an address cleaner works. And regarding common vulnerabilities, unfortunately, many people make mistakes when sharing their addresses. They don't use standard format, miss letters, forget zip codes, and much more. Some people may even enter the wrong addresses on purpose if they don't want to receive any marketing materials. As the input data is checked against a base of valid addresses, wrong addresses can generate unsatisfactory results, such as an address with bad formatting and fields assigned to the wrong places, or simply a match with an address that is different from the real one, due to a lack of specificity. For example, in ready-made tools and softwares, when problems like this arise, there's still the difficulty of finding the root of these bad results, basically being a black box. So why to use it, an address cleaner? To reduce errors and improve accuracy, to improve the data quality, and it fixes errors and corrects formatting issues. So the consequence is a positive impact on products and final user in several ways. So now let's talk about the protagonists of this presentation, the Brazilian address cleaner with NLP++. So at first, just like HTML or PHP, NLP++ is a text-based language. These code files can be edited with any text editor, but it is highly recommended that you use the VS Code NLP++, a language extension. And NLP++ is based on the fundamentals of trees. So, for example, if you ever diagrammed a sentence in school, NLP++ can do the same. Knowing the structure of language allows computers to know what words go together. There are noun phrases, verb phrases, prepositional phrases, and the like. NLP++ has data types and functions to create and use knowledge in a knowledge-based called the conceptual grammar. Conceptual grammar is a hierarchical knowledge-based system capable of housing linguistic and conceptual information. Knowledge can be created, ingested into a system, and used to understand text. NLP++ analyzers also create knowledge directly from the text, which can be used to generate new knowledge and understand the very text it is processing. So the heart of matching is NP++ rules. The syntax of NLPP++ provides you with powerful functions and notations, allowing you to define what you need in order to process text. You can define the context to match, the pattern to match, build meaning with the rule, and then produce a new tree if desired. You can put any meaning to any rule at any time. Once a rule is matched, you can create new trees and at the same time label meaning on parts of the matched pattern. Another important part of NLP++ analyzers is their ability to make general rules. One of the great limitations with text analyzers is trying to make sense of the flow inside an analyzer, not with NLP++. Each file can embody a clear modular set of rules, such as money, dates, companies, events, and an output. Each text analyzer is made of a sequence of files containing the rules, or NLP++ language, and each file builds on the previous files, and you can see exactly what the analyzer has matched each step along the way. So NLP++ has some advantages over machine learning and neural networks, including that NLP++ can be developed on a small set of data using humans' ability to generalize. NLP++ can explain how you obtained its results, so it is like a glass box. There is no need of a large training data set, and it is easy to identify possible improvements in a P++ analyzer. And regarding the advantages over a human being is that NLP++ has a reliable memory for large numbers of codes and terms and never tires as humans do because it is a computer. So about the materials used on this project, a sample with value addresses in Brazil and within the correct standard was used to develop our analyzer. Brazilian addresses are composed of the street name with an address type in the beginning, which is equivalent to an avenue, street, or highway, for example. The number of the place. If the address given is reference to a house, there is only one number to be informed, but if the place is an apartment, not only the number of the building must be present, as well as the number of the block, if there is one. The number of the floor in an apartment, the neighborhood, the city, the state, which must be informed by abbreviation, and the postal code. It is important to note that although there is a standard format for Brazilian addresses, some information is not required, such as the complement, that is the address line 2, which is used to inform the apartment where the person lives, for example. And as mentioned above, it is common for the address provided by a person to have flaws, such as typos or simply wrong information. Well, about dictionaries, dictionaries allows us to be clear by reinforcing the clarity of each word within the context of the larger phrase. And we use dictionaries to reinforce our natural language processing. Dictionaries can, therefore, be created for various sets of words. For this project, dictionaries were created for each part of an address and the possible values of address line 2, for example, for numbers, for Brazilian states and cities, and street types and names, for examples. So here we can see a few examples of dictionaries and its in common values used on these dictionaries during the construction of our analyzer. With the dictionaries created, it's time to create your rules and functions to identify the parts of a text. For example, here we can see the rule created to identify numbers in an address, which can be a postal code or a house number, for example. And the function then classifies the number as a zip code or not. Meanwhile, each step of a natural language processing can be analyzed, as seen in the image on the right, in which you can see the matched rules, in this case, the numbers. And here we can see highlighted that NLP++ shows which words matched with a rule. So we can see highlighted, for example, with the fired word on the image. As you can see with a few addresses, step by step, rule by rule, we keep incrementing the analyzer until we build a full address analyzer. With an address identified, the knowledge base can be built. With the help of the dictionaries also created, we can detect each part of an address and eliminate abbreviations or typos, for example. Now, to integrate the analyzer created with HPCC, the created knowledge base is converted to a XML file because HPCC works really well with XML. The indentations in the XML serve as the nesting in the record, and thus all the information of an address can be converted to a record. With the results generated and addresses cleared, we can check the effectiveness of the analyzer. First, let's compare the input data with the output data from the current address cleaner. The fields highlighted in green indicate those that have been cleaned correctly by the cleaner, while the other fields have been assigned to the wrong field or have been inferred to different values from those presented in the input data. Now, when we compare the results from address cleaner with NLP++, we see an increase in hits, and which are again the fields highlighted in green. And this was only possible because throughout the process, we were able to see possible points of improvement and address them with new rules, improving the analyzer even more. So now we can see that almost every field was correctly cleaned by our analyzer made with NLP++. This shows the potential of NLP++ to be used as an address cleaner. If you have any questions, feel free to contact me. This session will be followed by our academic partners at RV College of Engineering, so be sure to stick around, and thank you very much for watching.
Thank you, Guilherme. Thank you, Guilherme, for your wonderful presentation. Hello, everyone. I'm Nihar Mandahas, and I'm a student of computer science here at RV College of Engineering. And today we are here to present our topic titled Enhancing Legal Assistance via HPCC Systems. So before we begin with anything, we'll have a team introduction.
Hello, everyone. My name is Arya Hariharan, and I am a second year computer science and engineering student at RV College of Engineering in India.
Hello everyone, I'm Pratheek. I'm currently studying computer science in Arya College of Engineering.
Hello, I'm Skanda, a second year computer science and undergraduate studying at Arya College of Engineering, India.
Hello, my name is Manvith. I'm currently studying computer science in Arya College.
Thank you, everyone. And we'd like to extend our thanks to our mentors, both from Arya College of Engineering and from HPCC Systems. So thank you, Dr. Shobhaji and Dr. Jyoti Shetty, for providing with this wonderful opportunity. And we'd also like to thank Mr. Hugo and Mr. David from HPCC Systems for constantly guiding us through this project. So let's dive into the project. So what was our main motivation to choose this topic? So as you might all have heard, the crime rate here in India is escalating at a very high rate, and there are millions of pending cases here in India, and they have been pending for over decades now. So this clearly indicates that there is a requirement of new age technologies and tools in this field. So obviously leveraging new technologies like natural language processing and big data systems like HPCC systems might seem meaningful as they simplify the process of analyzing huge corpus of legal data. So this was our main motive for the function for the project. And going to the objectives, so we are gonna build a platform. We have already built a platform that takes in the user input, which is a brief abstract of a case that a user is fighting. So the user is generally going to be a lawyer, but it is not limited to a lawyer. It can be a normal individual like you and me as well. So this abstract is then search for keywords using artificial intelligence, that is of NLP. And these keywords are then used to get references from a huge data corpus that is in the HPCC cluster. So that's the objectives of this project. And here's a brief overview of the project. So we can see there are multiple components of this project, starting with the interactive web platform. So we have built this web platform using two components. For front end, we have used React framework, and for the back end, we have used a simple Flask application. So on the interface, that is the front end, the user generally enters a brief abstract. So this abstract contains all the information about the legal battle a person is fighting currently in the court. So this abstract also contains all the important keywords and also the constitutional articles and laws under which the case is currently being fought. So with the help of NLP technologies like named entity recognition, we're able to extract keywords that are relevant from a legal perspective. So this combined with our huge data corpus that's already in the HPCC cluster, we write a program that basically searches these keywords in all of the data corpus, and based on that, it filters out the relevant references. So these references are then further processed and ranked based as most relevant to least relevant based on the constitutional structure of India. And then this list of references is returned to the user. So that was a quick description of the project. So let's dive deep into the technology.
So now I will be talking about how we leverage natural language processing or NLP to search for keywords and key phrases in the abstract entered by the user. So the first step in the application workflow is for users to enter in a case abstract from which relevant key phrases or keywords are extracted. This key phrase extraction is done using a natural language processing key phrase extraction model. And the goal of the model is to essentially identify any relevant legal terms in the abstract, such as courts, judges, statutes, and so on, and make them available for further processing, which will then be later used to search for references. So we investigated different methods to implement this key phrase extraction model. The first one involved models that followed unsupervised machine learning techniques. However, these models did not provide satisfactory results. Often, key legal terms were not identified as key phrases within the abstract, and other terms that were not relevant to our use case was identified as a key phrase. And thus, it did not provide the level of satisfaction or accuracy that we required for our application. So we moved on to testing out models that followed supervised machine learning techniques, and these provided much more accurate results. Particularly, supervised named entity recognition provided the best possible results. So named entity recognition is essentially a method in which you train models on a data set where the data set is annotated with entities or labels, and it is trained so that later on, given any sort of text or input, it is able to identify and label those entities within that text as well. The named entity recognition model that we used was developed by OpenNY AI, and it can recognize up to 12 different legal entities, as you can see on the right. It includes bench, case, case type, court, etc. It was trained on an extensive data set of pre-annotated sentences, and the data set was curated by legal experts and data scientists at OpenNY AI. So this model can identify any of these 12 legal entities in the user-entered abstract. So this is just an example of how the named entity recognition model works. Given an input, it identifies relevant legal terms and also assigns an entity to that term. So in this input, it has identified section 319 as a provision and CRPC as a statute. It will similarly do the same for any given abstract. And this keyword identified along with their entities are made available in a suitable format for further processing later on. Now, my teammate will continue and talk about the data set that we used for searching.
Hello everyone, I'm Pratheek and I'm going to discuss about the dataset we used for our project. After our NLP model extracts relevant keywords from the case description, these keywords are then used to search for relevant legal documents in a large dataset. This helps users quickly and efficiently find the information they need. For this purpose, we chose to use ILDC dataset, which stands for Indian Legal Data Corpus, a highly valuable and extensive dataset in the legal field. The ILDC dataset is a comprehensive collection of legal documents, including judgment, orders, and other court proceedings from over 35,000 cases in the Supreme Court of India. This dataset is crucial for legal research, especially for projects like ours that aim to make legal information more accessible and streamline legal research. ILDC dataset is open source, making it available for researchers and developers who want to explore the vast collection of Indian legal documents. It offers a wealth of information that can be used to analyze legal trends, judicial precedents, and how legal interpretations have evolved over time. This makes it an invaluable tool for understanding how legal decisions are made and how laws are applied in India. In our project, the process starts with the user entering a court case description. The NLP model in our system then extracts the most relevant keyword from this description. These keywords are important because they serve as search terms to find matching legal documents within the ILDC dataset. The ILDC dataset is huge, containing numerous legal documents, judgments, and court proceedings. Managing and processing such large dataset requires a powerful platform that can efficiently store, process, and retrieve data. HPCC is ideal for this, as it's designed to handle big data workloads. HPCC's ability to quickly retrieve data is crucial for our project, as users expect quick and accurate results when they input a court case description. In conclusion, the usage of ILDC dataset allows us to bring a strong and efficient system that improves access to legal information. By using these powerful tools, our project can provide quick and accurate access to the information users need, ultimately enhancing legal research and decision making. Thank you. Now my teammate Skanda will explain how the integration with HPCC system was done.
Hello, I'm Skanda and I'll be sharing insights on the different searching techniques used to retrieve the data. We tried out different approaches for searching relevant cases from the data corpus. They are sequential searching, searching using dictionaries, and index searching. Coming to the sequential searching, it is a technique in which each record in a dataset is examined one by one to identify matches based on specific criteria. The methodology is as follows. First, we will start with the extracted keywords, which contains records of text ID and its associated keywords. Next, by employing the inner join function, we will match the extracted words across the entire dataset. Subsequently, we calculate the frequency of each text ID based on how often the words appear. Finally, we use the matched text ID from the previous dataset and map these text IDs to the original case statements to retrieve the case statements of the respective text ID. The drawback of this approach is that sequential search involves scanning the entire dataset, which can be time consuming even with optimized services like Roxy. Going into the dictionary searching method, a dictionary is a data structure that stores key value pairs, enabling efficient retrieval of values using their corresponding keys. The steps in searching are, first we will match the extracted words across the entire dataset similar to the sequential searching. Next, a dictionary is created for the dataset containing the original case statements, mapping each text ID to its corresponding case statement. Subsequently, we develop a function to retrieve the case statement corresponding to given text ID by using the dictionary. Finally, the transform function is used to call this mapping function each time, enabling the mapping of each text ID to its corresponding case statement. The advantage of this method is that once dictionaries are created, they allow for quick retrieval of case statements based on the text ID. But when each time a Roxy query is executed, the dictionary is recreated, which is time consuming due to the large size of the data. While sequential search and dictionary methods offer structured approaches to the text analysis, they are inefficient for large datasets due to their time-consuming nature and are therefore not ideal. Hence, these methods of sequential search and dictionary-based mapping are not used. Index searching method is the current method which we are using, which overcomes the drawbacks of other methods, as it significantly reduces the time required to search for relevant case statements based on the provided keywords. The steps in searching are: we use build index to build the indexes for each record in both the datasets and use this index dataset in the key join function. Whenever the indexes are built, a binary tree of the dataset is created. The binary tree meta key is a separate 32 kilobyte file part located on the first node of the Thor cluster where it was built. What makes this method fast is that this meta key will be deployed to every node of the Roxy cluster. Hence, when the key join operation is performed between the keywords and the index file, the required case statements will be fetched rapidly. The index searching method is much faster than other data access method, making it an ideal choice for efficiently handling large data sets. Now, my friend Manvith will continue about the web application.
So moving ahead, and myself, Manvith LB, and I'll be giving an insight of how we used web app and how we integrated with our HPCC system. So let's start with the front end of our system, which is built using React. And for building components, we used Chakra UI, which makes it easy for building components. So it's designed to be really user-friendly, allowing users to input code case details with ease. So the idea was to make sure that the entering complex legal information feels straightforward, and once the details are entered, the system prepares this data for the next step, focusing on the simplicity so the users can quickly move through the processes. So the second step is the process of integration of website with the NLP model. So the heart of our system lies in the NLP processing. When the user enters the abstract and the user presses enter, extract button, so the keywords from the front end sends this to the Flask API. And when the code case details reach the backend, the NLP model goes to work extracting keywords that are crucial to understanding the case. Since the legal text can be pretty dense and complex, the model is fine-tuned to handle this specifics, making sure that the keywords is picked out are relevant and accurate. So these keywords are what help legal professionals quickly get a grasp of the case core points. So once the keywords are extracted, they appear on the front end for the user to review. This is a key step because it lets the user double check the keywords and make sure that they're correct and can edit and remove or even add new keywords if needed. So the goal here is to make sure that the final list of keywords really reflects the case details. We designed the interface to make this review process as smooth and as straightforward as possible. So after the keywords are reviewed and finalized, user can submit them. So for submission, we had two options. One was directly to the Roxy endpoint or through the proxy server. So we choose to have a proxy server in order to safeguard our token or the authentication token. So once the user press submit button or send request to Roxy, it triggers a process where the keywords are sent from the front end to the Flask API, and that is the proxy server, and from the Flask backend to the HPCC Roxy. Once the Roxy processes the keywords, it sends back a response in the form of code cases where it's ordered with how relevant they are. And this code cases is displayed to the user, and we have given the option to view more in order to see a full case details in it. So the whole system from the React front end to the Flask backend and to the NLP and the HPCC Roxy works together to make sure that the process is as efficient and accurate as possible. So each part is designed to make sure that the user can enter, review, and also submit their information with ease, while also ensuring that the data is processed accurately and quickly. So the conclusion, and in the end, the system is all streamlined the way the code case details are handled by combining user-friendly design, advanced NLP. So this system not only efficient, but also enhances the accuracy of legal work. So to ensure that our system delivers the fastest and most reliable search result, we conducted a performance comparison using three different platforms. That is HPCC system, Hadoop, and the multi-threaded Python application. So the HPCC systems, so the task was to search for relevant code case using the keywords extracted by our NLP model. So So the results were telling that the HPC system delivered the results with an impressive latency of just 1.7 seconds, and Hadoop took 6 seconds to complete the same task, and the multi-threaded Python application had the longest latency of 30 seconds. So this comparison clearly demonstrated the superiority of leveraging the HPCC systems in terms of speed and efficiency. So by selecting HPCC system, we ensure that the users can access relevant cases information almost instantaneously, making the system not only more powerful, but also more user-friendly. So thank you.
Hello, I'm Pratheek, and I'm back to show you the demo of our website. As you can see, the front end of this website was developed using React. The website currently runs on a Flask backend, and we currently have localhost. We do plan on hosting the website once we are completely done with it. So as you can see, this is the input text where users can type in their case description, and once he clicks on submit, the extracted keywords will be shown here. If a person is not satisfied with the keyword, he can add his own keywords to include in the searching. And once he clicks on send request to Roxy, the dataset which I talked about earlier, which is stored in HPCC cluster, the keywords are sent to HPCC cluster and as a Roxy query, and it returns the relevant case description as JSON format. I already have a sample case ready. So this is the sample case in the HTML Karnataka High Court. Basically, this case talks about a property dispute between two families. And I click on submit. These are the relevant keywords we get. The one thing we noticed was these section 79, section 3. These are more relevant than the Karnataka High Court. So you have made the Roxy query such that these are given higher preferences. For example, section 79 and section 3, section 101 of Indian Evidence Code will be given a higher precedence over Karnataka High Court, since Karnataka is a state in India, and it doesn't depend much on which state the court in. The actual law, the cases talking about matters more. So we have given more preference on the sections and the acts of the law. As you can see, I can add a new keyword if I want. I'll just show you the example. And if I don't like any keyword, I can click on into mark to remove the keyword. Now I can click on send request to Roxy. Now these keywords will be sent to HPCC query. Okay, as you can see, once in the HPCC, once the keywords are sent to the HPCC, we get back the results in the form of JSON. We get the 10 most relevant cases, and initially it's like this. When we click on view more, it shows the complete case description. As you can see, there are around 10 most relevant. It's ranked from most relevant to least relevant cases. Thank you.
All right, so thank you very much, Pratheek, for the great demo. And by the way, congratulations to all involved in this project. I'm sure participants watching this presentation might have several questions that they have regarding this project. And remember, you can post your question in the Q&A area of this session. And students, if you don't mind, there are a few questions that have been submitted in advance that it would be great if you could address. So the first question is actually related to the original process or the original motivation behind this project. While we understand that the project was developed in partnership with faculty from RV College of Engineering and members of the HPCC Systems community, would you mind talking a bit about what was actually the original spark for this project? In other words, how was the initial process behind coming up with this, original idea? Would some of you be willing to share a little bit about that?
Thank you so much for the question. Really appreciate it. So the original idea was not from any of us. It was from one of our college seniors, actually. He had participated in the annual poster competition, which HPCC Systems conducts every year. And this idea was really liked by both mentors from HPCC Systems and from the faculty here in RVC. But sadly, the senior could not continue this project as he got busy with his internships and placements and stuff. So the teachers being really interested in this, she contacted all of us. Since we are in the same batch, computer science, she contacted all of us, and we were really interested to work in this. And that's how all of us got together and analyzed what the seniors' ideas was, and we came up with our own inputs to the idea as well. And that's how we are here today.
All right, well, thank you so much, Nihar. And another question that came up is actually regarding the practical application of this project. So it appears there is a lot of relationship with the legal industry, for instance. And the question is actually, how do you know that the method that has been developed here actually makes sense and it's relevant from a lawyer's perspective?
Okay, thank you for this question. So to ensure that our approach was practical and aligned with the legal professionals, we did conduct a session with a lawyer who reviewed our project completely. And the lawyer provided valuable feedbacks. So one of the most important feedback was adding the statute and the provision together as a single keyword. Because just statute, for example, section 31 doesn't make sense. And even just provision, just like Indian Penal Code, doesn't make complete sense. So adding those two together, section 31 of Indian Penal Code, makes more sense and is more, the keyword has more weightage on it. So this feedback not only improved how legal profession sees these keywords, but also increased our accuracy. So this collaboration helped us refine the system to better serve the real world needs of lawyers, ensuring that our extracted keywords and overall user experience both are relevant and effective.
Okay, well, thank you for that insight, Manvith. And then another question, I guess, more related to the operational aspect of the solution. So even though this initial version of the application is based on a data set, the question is actually if the data set can be updated, and if so, can be updated at real time. Would someone be able to answer that question?
Thanks for the question, Hugo. Yeah, the current data set we are using is a static data set. It's an open source data set. But if we want to extend this project to include real-time database, there are lots of APIs available, but they do cost a bit of money. Since this is academic project, we stick to the open source data sets, which is the ILDC data set I talked about earlier. So yeah, this can be extended to include real-time database, but for now we have used a static open source database.
Well, thanks for that clarification, Pratheek. And I guess a question related more along the lines of what the future holds for you. So what do you anticipate as a continuation for this project if any activities are already mapped? Would someone be able to answer that one?
Yes, thank you for the question. I'll start off by saying this is like I can speak on behalf of the team, that it was an amazing experience for us. We learned a lot of new technologies that we weren't aware before we started this project. It was a huge learning curve, and as Manvith said, we were fortunate enough to also get in contact with the legal community and actually validate the purpose of our application. Now we feel like it's time to also get in touch with the technical community as well. We want to put our idea out there and get reviews, talk with our peers in the technical community as well. And we believe that the first step in doing that is to have a research paper that, of course, will be shared with the technical community. So that is what we are doing right now. We are in the process of framing a research paper, and hopefully that will be getting published very soon.
All right, Arya, I'm sure it will be published. And I guess just to conclude, since we were talking about experiences and learning opportunities, I believe this probably represents the first industry project each one of you had a chance to work on. So if you have to pick just one thing, what would you say was the main takeaway you're getting from this experience? It could be a personal experience or maybe a technical skill you have acquired. I guess maybe each one of you might want to say something about it.
So yeah, this was the first industrial project all of us worked on, and it was really amazing. We learned a lot of skills actually, apart from the technical skills. So we learned teamwork, and we actually got to interact with amazing mentors such as yourself and Mr. David. So that was really helpful, and we learned a lot from all the mentors. Thank you.
Yeah, and for me, the most important takeaway was the collaboration we had and with the industry analyst. And for example, we had every month meetings, so we get insights about how we can improve our project. So these meetings and with how we give our progress, how we like say what we had in this much progress. This was something which I learned in this project. And the second thing is the technical aspect. I learned mostly the React, how to build project with React, and how to use Chakra UI, which is a component builder. So all these technical skills were also something that I learned in this project.
So for me, the biggest takeaway apart from learning various new technical stuff was working with a team and knowing what it takes to collaborate and work on a complex project such as this. Even though all of us are batchmates, I feel like by working on this project together, I feel like I know each one of us a bit better, and I'm thankful for this opportunity. Yeah.
I learned about how to work as a team together and what are the different ideas which each one of us gave, like which helped us to complete this project. And the second thing is like it is technical. Like I learned a lot about HPCC systems, its functionality, and about the Roxy services and stuff like that.
Okay, good.
Yeah, as I mentioned earlier, it was an amazing project for all of us to work on. Particularly, I am interested in NLP, and I would say that this was the first project in which I was really able to hone my skills and actually implement a solution related to natural language processing and learn a lot more about big data and HPCC systems as well. And a lot of soft skill development as well. As Manvith said, time management was something that was a big takeaway with the monthly meetings being on time. We had schedules that we had to meet, and teamwork, flexibility, all of these were also built on the course. So yeah, very grateful for that.
All right, thank you so much, Arya. Well, thank all of you for that great testimonial. I guess at this point in time, I just want to say thank you for all your efforts, your mentors, the faculty from RV College of Engineering, and congratulations again for this great presentation. I'm sure students joining us here today will be motivated to follow your steps and also join similar activities in the future. All right, so with that, if there are any other questions from the participants, please remember to post them on the Q&A area, and we'll stay around for answering those questions. Thank you so much, and stay connected for the next sessions throughout the day. Bye-bye.